Good afternoon. Are you
Good
able to
afternoon,
see the
sir.
screen?
Yes, sir.
Yeah,
Yes, sir.
thank you. So I hope you have started downloading papers.
So, can we send you the project title and you can confirm it if it's okay or not?
Sorry,
So, can our team send you the project title and confirm that it's okay or not?
I shared with you a form.
Yes, sir, I know that.
Okay.
So, just I wanted to know that if the project title is it's okay or not.
Project title. Did
Yes,
you
sir.
share a project title?
So for that we had to write our project title also and domain also, and then the word file and all.
I don't think so. Did I ask a project title? Okay, no problem. You can write a project title also. Of course, you need a title.
Yes, sir. So only I'm saying.
That we can do it at the end. No problem.
Okay, sir.
Okay. And it is very fortunate that I have received so far 4 submissions. Very good. 4 submissions. So tonight I will try to respond to them. Okay, whether the papers are okay or not. If not okay, I will let you know which are the papers to be changed. Okay,
Okay,
different
sir. So
papers you may look
so
into.
we had to write the specific problem chosen. So it's like similar to title only.
That is okay. That we will do. We will do later. Once we finish the work, then we will give appropriate title. Okay.
Okay, sir.
Ah. So I'll go through the papers. If the papers are not okay, I'll tell you which are the papers are not okay. Otherwise, I will go with the uh, rest of the things. Okay, you can start your work to write an abstract, single page writer for every paper. Okay, as per the questionnaire I have given to you, right?
Sure, sir.
Okay. So let us discuss about the applications of NLP. We will quickly go through. Okay, I have 2 classes, continuous classes today. So anyhow, okay, let's see. The most common tasks under NLP research, we already discussed about syntactic thing. The last class we discussed, we have a lemmatization, morphological segmentation, and so on. These are the NLP related tasks, which is considered for syntactic knowledge. Okay. So likewise, we have semantic knowledge also. There are some specific tasks under NLP research for semantics. Lexical semantics, distributional semantics. So lexical semantics is about understanding about a word, what's its meaning, what's its surrounding, and so on. Distributional semantics, of course, it is we try to match multiple documents, multiple different sentences, right? In a vector space, something like that. That is, but through that we try to match the texts, right? That is distributional semantics. Machine translation, that you know, it's an application. We translate from one language to other language, right? Machine translation. Named entity recognition, it's about recognizing the named entities, real world entities, maybe a name or a number or a person and so on. That is named entity recognition. This is related to semantics because we want to understand the meaning of the text. Then we need to understand what are all the entities present in the text. And natural language generation and understanding. So understanding and generation, we may give a answer through speech or answer through text again. So that is required for natural language generation and understanding. Optical character recognition is about uh, that is scanning a text and extracting the text from the scanned documents or written documents and so on in a text based method, right? And question answering is you are given a question and we are looking for an answer for the question instead of uh, information retrieval. Just suggesting set of documents, we are interested in knowing the answers, direct answers for given questions. Relationship extraction. So if you mention for example, a named entity, and in the same sentence I mean to that entity, or there are different entities. Okay, so we want to extract the relationship between two different entities like this. So how these entities are linked? That is again a semantics based. Okay, it's common NLP tasks. Sentiment analysis. I want to identify whether it is positive, negative, or neutral comment. the comment which is made by a customer, for example. We want to analyze that. Is it a sentiment? That is a semantics based one. And finally, word sense disambiguation, we have discussed enough on that. We want to find out the exact sense of a particular word in a given context. Okay, so these are all the common tasks under semantics, and some of them are direct, considered as direct NLP applications. We will discuss some of these applications now. Okay, for example, first one, spelling checking, spell checking and grammar checking. Okay, so these applications, we check for the spelling. If the spelling is not correct, then we are going to suggest an alternate for that. If the grammar is not correct, we may suggest something. So you might have seen it in a mail, Gmail. When you type your mail, when you compose your mail, the system automatically suggests something, right? So this is a grammar. Or if I made a mistake, the system automatically changes the spelling of the word. You might have seen it in Word also, right? Word, Microsoft Word, when you type a document, you will understand if you made a mistake, it automatically identifies that, or in some cases it automatically corrects that. Okay, so how it is possible? It is possible by identifying the context in a text, entire text. This particular word may not correctly fit into this text. For example, you see here, Google, Vellore Institute of Technology, I miss one L here. So that system suggests automatically VELLORE instead of technology, because this spelling is most frequently used spelling for Vellore, not this one. So the system is able to correct it statistically. Or it may use some ideas called edit distance, minimum edit distance. Something that spelling is given here. I have a vocabulary. This word does not match with any of the words in the vocabulary. Hence, it might be misspelled. Or this word may not be part of this dictionary. One case, the other cases, the spelling may not be correct. Okay, so in that case, there are really possible that more than one word may be close enough to the misspelled word. Okay, something maybe like there may be a place VELLORE. VELLORE may be the actual word, or maybe VELURE is an actual place. So something like this. Okay, so here statistics involves always a minimum edit distance. That edit distance, which changes from this misspelled word into the correct rightful word, which is very close enough. So such a way we can check the spelling. These are the very basic problems: spell checking and grammar checking. Word prediction. For a given word, for a given sentence, or if I start typing something, so the system automatically recognizes what might be the next possible word. Right? Most of the cases, it's very easy to recognize because of the availability of the text already, the evidence in a particular language, how the words, how this vocabulary could be used in a particular language. There is an evidence. This is the way we can use. We cannot go beyond that, right? For example, the statement which I have uttered, we cannot go beyond that. We cannot go. What are the possible things? Beyond is one of the possible things. The system is going to predict. And of course, it uses a probability, the most probable next word to be used, word prediction. We are going to talk about something called language modeling. So that includes that, it gives a solution for this word prediction and so on. Information retrieval. We discussed during a class about the working of Google, a search engine or a search engine. It collects the data through these web crawlers. It identifies the new web pages, the content of the web pages. It downloads them, and they analyze the text, extract the keywords, and store these pages as a database, into a database under some keywords getting indexed. So when somebody is searching for some query online, maybe Google or Yahoo, whatever it is, they are going to search through their database only. They are not going to search for entire internet for the possible web pages. Instead, they are simply searching in the set of documents using the index available, so that we can perform this retrieval quickly. So information retrieval, for example, who is the father of computer? It gives an answer immediately. I just give you a screenshot. The remaining is not given here. See how many pages are listed? Almost 100 crore pages. 100 crore pages which are retrieved in 0.71 seconds, less than a second. Less than a second, the system is able to get you, suggest you 1 crore page, sorry, 100 crore pages, which are very relevant to the given query, right? And information retrieval is not just that task alone. It is also about recommendation. It's also about uh, ranking of documents, how it is going to rank the documents, because not all the 100 crore results are very well relevant to this one. They have found 100 crores, but they are going to project you some of these things, not even 100 crores. You may go through this one, next page, next page, next page. Can you find all the 100 crore pages? No, it is not. Some pages, up to some pages, you can see. In this list, what you get in the first page is very relevant to the user query, or considered to be very relevant to the user query. So ranking is important. I have to analyze the text, and I have to compare the text. I have to compare the text to the other text. I have to compare the text with the input query. Then I can project the result. So that is what happening in information query. This is an application of NLP. Text categorization. If I give you a text, if I give you a paragraph, I want my system to read through this text, right? Analyzes it and categorize it into different several categories, predefined classes. Okay, so where it is useful, for example, web page categorization. We want to categorize these web pages. Somebody says that, for example, you go with the developing your web page, you want to list the web page, or you want to generate the web page, right? Or you want to purchase a domain for your web page. Now, these kind of cases, they are going to ask the person what kind of web pages it is. It is about education, it's about industry, it's entertainment industry, whatever it is. Okay, so like categorization, it automatically categorizes. Customer feedback classifier, because that is very, very important nowadays, very much required one, right? So because plenty of customers every day, every now and then, hundreds of thousands of people are giving some comments. So we need to analyze those comments to understand. Sentiment analysis is going to be useful, of course, right? But categorization. So for example, it is about, these comments are about furniture as a whole. Then it's about particular product, maybe a chair. When chair, it is about some particular company's chair, and so on. So we want to categorize, because we cannot read them using human being. It may be difficult for going through all these content. So we may need a machine that can automatically categorize them. So finally, we are just going to look into individual categories which are required. Language detection, it's also text categorization, right? For example, here you see there is a system called U Classify. It's an online extract. I have taken it. I have typed something in Tamil, India Pradhamar. It is Indian Prime Minister. I have typed something in Tamil, and the system classified it is entirely 100% it is Tamil. 100% it is Tamil. It is recognizing, categorizing the input based on the text used, the language used. Okay. So these are some of the applications. Summarization is another very, very important application. So what you are doing, I ask you to go through papers, from top to bottom, understand that, answer some question, generate some abstract out of it. So instead of that, doing that, we feed the system the uh, text document, and we expect a one-page write-up from the text document. Okay, so such a system, of course, it is an open problem. We have not at all achieved that 100% solution. We have achieved, of course, we have extracted some content from the given document which are considered to be important, then we are projecting them as a result. That is not the correct results, right? We want to rewrite something in our own, in an abstract way, That is what expected in summarization problem. So it is one of the NLP applications. Question answering system, it involves information retrieval system. So whenever we say some applications, the basic starts at the several stages already we have discussed, right? Before last classes, before discussing the project component, we have discussed what are the several stages, right? We need to process the text pre-processing. I need to tokenize the input text. I need to understand individual words. I have to find the root words of individual words, then take the meaning of that. Then once I understand that, once I learned that, I need to remove the stop words. Then again, once again, I have to combine everything. I take the sentence as a whole. I need to parse the sentence for meaningful structure. Then I will take the next level as a whole. What is the meaning of the entire text? Okay, instead of the literal meaning. like, and so on it goes. Likewise, when I take a question answering system, what is a basic thing? Question answering system, if I give a question, it is going to answer me, directly give the answers. So where would I find an answer? Answer is available there in some documents. So what are all the documents contains this answer? So of course we need information retrieval. I have to search my documents, I have to find the best among them and choose the one among those best, and inside that I'm going to analyze the text for answering these questions. See, this is a START system, START question answering system. It's developed by MIT, USA, right? These are going to some kind of use something called annotation. Okay, so using natural language annotation. So we annotated everything in a corpus, like every word is a what type of uh, category, word category is here, what type of phrase is here, is it a named entity, what type of named entity, like many things, what are the things possible. We have our corpus, a training corpus with complete details. So such a kind of annotation is used to answer these questions. Likewise, another system, this website is not available and not accessible nowadays. I don't know why. So they are developing a question answering system based on the DBpedia, that is Wikipedia database. Wikipedia database, because Wikipedia have almost all the documents about everything in the world, right? So what is your question? Your question is consists of a keyword. Then I'm going to go through Wikipedia. I may find a document, not multiple documents. Maybe very few documents are already about this particular keyword. Then I can go through, analyze entire maybe few pages to get an answer for this one. And again, in question answering system, this is also an open problem exists there. It may be like who, what, where, what, when. All these questions are directly answerable, easily answerable, because the answer itself like this. Who is the president of USA? The president of USA is something like that. The text will start like that. It's very to extract an answer for that kind of questions. But still we have problems with the questions which asks why and where. Sorry, why and how. Because these questions we may not have direct answers. Some website, for example, if you give why is it so, right? Now, if you search it in the Google search engine, it would normally suggest Stack Overflow, Quora, like this. It's going to suggest, because there they put the question like this. Somebody raised the question, this question is going to be answered. But in real document, there may be a book available in online, right? That book may consist of the answer, but not directly. We need to extract the answer from the book. So such kind of things are still open problems. Okay, so in question answering system applications. Information extraction, it includes named entity recognition. As I told you, when I say Bell, here this example is given. Bell, a telecommunication company which is based in Los Angeles, makes and distributing electronics, computing and building products. Now out of this paragraph or sentence, Bell is a named entity, Los Angeles is a named entity. So that is what we are extracting. Named entity recognition is above. So there are many tagger are also available. They are going to tag the given sentence as per the named entities. For example, Mercedes-Benz is a German global automobile mark and a division of Daimler AG. Now this system is able to recognize and match with the potential tags. So this is very old one. We have very limited tags, but later they have developed many tags. For example, if you check for the Illinois Institute of Technology, that's entity tagger, right? They include some more tags. So maybe like date, time, currency, something like this. So it will give you more meaning to a text. Even if you find this one, it recognizes German as the miscellaneous. So what does it mean by German? Because German might be possibly it points to a person, a German, a person from Germany, right? Or it may be a language, right? So there is a confusion. So it recognizes under miscellaneous. But we have more taggers, we have more specific meanings. So this is about information extraction. Of course, there are some openings there. Machine translation. So Google works very well, of course. Up to 2006, they have started with the Google machine translation using statistical process. They have enough data. Because every day people are interacting with Google. they upload something into website, something they are developing in a blogger. So Google have enough data to understand the usage of a particular language, right? So it uses statistics and finds the data. But later, because of some drawbacks, they have started using neural machine translation based things. Somebody have talked about BERT, right? Bidirectional some transformers. The transformers are very much useful nowadays. That is developed by Google only. They are very useful in handling natural languages, right? So such an improvement is there. But still, if you see, other day I have started discussing a problem with a Tamil sentence. Avan en kannathil araindan. He slapped me on my cheek, right? So when I say araindan is used as a verb. When system recognizes araindan is a verb, under verb there is only one meaning is available, that is slapping, in equally in English. But the same sentence I put in a different format. Avan en kannathil oru arai koduthan. Now this array is a noun, but as a noun is translated in English. We have two different possibilities. One is slapping, the other one is room. But which one is more probable is room, because it does not see any evidence related to the usage of avan en kannathil oru arai koduthan. So it wrongly recognizes it. But this can be solved when I link two different things. Arai with kannam, slap with cheek. So can anybody give a room on cheek? It is not possible. So in real world scenario, I can match the second one, but it uses the statistical processing. It shows the most probable word. So of course we have scope in this case. And most of the machine translation systems, we use something called a parallel corpus. The corpus have the translation of the one text into other. Suppose if I want to do it from English to Tamil, I must have the corpus in English, the same corpus in Tamil. Such thing is called parallel corpus. So that is very much useful in machine translation also. Sentiment analysis, you might have gone through many things. I want to identify whether the customer is happy about our services or not, right? Whether they give a comment about happy or neutral or negative. Because the reason is I cannot go through all these comments manually. Okay, so some new seller is coming in, and he is selling products through through Flipkart, right? Now he is a newcomer. If somebody is going to comment, he can watch the comment, he can understand the comment. But think about those sellers who are already very popular, very popular. Maybe the direct companies who are selling the products through Flipkart or Amazon, something like that. They don't have time to go through all these comments, because there are hundreds of thousands of commands. Okay, so now for this, handling this, so any online solutions, any online surveying, where we need system for analysis, sentiment analysis. Okay, so that is another important application. Optical character recognition, I told you. Suppose if it is written in English or written in some paper, or it is a scanned copy of something, or if it is a text is taken as a Xerox, we want to convert that into text by scanning that particular thing. That is optical character recognition, especially involves languages, natural languages, right? That is optical character recognition. Speech recognition, some of these systems, they are able to understand your speech. How they are doing it? Whatever you speak to these systems will be converted into text. Then it processes the text, then it is understanding the text from the text. That is what the speech recognition systems are doing it. We have plenty of examples nowadays. We are using every day, we are using these systems. Speech synthesis is speech generation. So how these speech recognition systems are going to respond? For example, Siri, it's going to convert into text, analyze the text, understand the text, and make the answer in that text itself, then convert that into speech. Like that it is doing. Speech synthesis is another application of this one. Spoken dialogue system, of course, the chatbots. I can type something, that system is going to respond me with the text, or I can ask something like Siri, it's going to respond me with a possible answer. These are the spoken dialogue systems. So these are some of the applications, not entire applications. I just gave you some of the applications. And spelling, text categorization, NER task, named entity recognition, these are all considered as easy applications. In any languages we can do. So, okay. So what is the scope of these applications? I cannot say that all these are available in our language. We have a best solution. We cannot say that we have a best solution for all these problems in our own language, especially in our own Indian languages, because we don't have enough sources. We don't have enough corpus, right? So we don't have enough evidence, recorded evidences, so that we can use it for some natural language processing. But there are some companies are doing. So Google is collecting our usage, language usage, so it can make some neural based, neural network based machine translation users. But in reality, it is not like that. Okay, so we have scope for our own languages. These applications may be existing for English or some other well studied language, but not for most of the Indian languages. So even if you can take any of these applications in your own language to find a possible solutions, right? So medium, information retrieval, sentiment analysis, machine translation, information extraction. And I mentioned question answering, summarization. Summarization is still an open problem. Still an open problem. It is difficult to process because I have to understand if I want to answer the question, I may get an answer from the question from the document, but I need to summarize the answer. For example, why is it happening so? So I have to understand what is it about, where is it happening, when it is happening. All these things may be available with that one. I need to extract the fact why it is so. From not only from that document, I may need to search through several documents to answer the why part. Okay, so that is why they are considered as, some of the applications are considered as difficult applications. Okay, so not only these difficult applications, we have many more applications: POS tagging, paraphrase detection, automotive virtual assistants, computer assisted physician, most of the automated consumer services. And I've assumed that, so remember that in each of these applications, we need to start with the pre-processing. Of course, we need to do a lot many things even in the case of pre-processing. I need to break the sentence. I need to understand every word. What are the words are important, what are the words are not important, that is considered as stop words that need to be removed, remaining words to be retained, and so on and so forth. We have several steps to be followed. In each step, we have scope for doing a new research. Okay, so these are the applications. Do you have any doubts so far?
So can you tell a bit about this computer assisted physician thing?
Computer
Assisted physician, the
assisted
fourth
physician,
application.
nowadays you are using this, no, virtual assistants. It is exactly that thing. It's a system which is based on a particular domain, so it has a domain knowledge in it. So you may be asking your questions, so it is going to answer your questions. It's just like any other assistants, virtual assistants.
Okay, sir.
Doctor,
Okay, okay, sir.
yeah. See, ultimately, why they are using these systems, you know the answers, right? So they are telling the making use of making it available to your end users. We are going to type something. When the system is not going to give it an answer, it asks us to talk to the physician. Then this may be the cost to talk to the physician. Like that, they are attracting us towards some services, right? That is the reason. Yeah.
Okay, sir.
But maybe that may be entirely that we cannot ask the every question to the computer to treat ourselves, right? Maybe that system may be developed in the future. Somebody may develop that system. Of course, these are all open problems. Yes. See, please take care of your project work. I can understand your difficulties. You are most of your second year students. You may need to work a lot more to come up with some solutions. But if you do it, people are trying to get some papers. So nowadays, some companies are also expecting what is your research profile. If you have published any paper in any article, okay, they give the preference to those students. That's why we are insisting, right? And secondary things is, uh, many students who have studied under me, they are going for higher studies. Some US universities or European universities, they are going. So that time they need paper. Okay, so that is too late. You cannot go and publish a paper when you are going for applying for higher studies, or when you are going for sit for interview, you may not come up with a paper. This is the right time. If you start doing it, you will understand it. and also you may have a problem which can be elaborated further, and you will get a direction to work on. Okay, so that is why I've given this EPJ component to you. So please work with extra care, whatever things possible to publish it in a high profile, highly impact factor journal. I will try to do that. Okay, so that you may have a impact factor paper with you, maybe at the end of the semester or maybe end of the year, whatever it is. Okay, so to quite work hard, so take it seriously and spend that time for that purpose only. Submit the required things, and every stage I'm going to tell you what to do exactly. Okay, okay, any other questions?
Sir, the
Yes,
form which we have to submit.
sorry.
So the form which we have to submit.
Yeah.
Sir, in that we have to include that Word file. There you have mentioned clearly to mention the paper titles.
Yes.
Sir, so do we have to provide the link to the papers
No,
below the
no.
title?
You type the title of the paper in a Word file, and that Word file you upload.
No need to give you the links, sir.
No need. If you want to include the link also, no problem.
Like, sir, some papers are there which can't open from the link also. I have downloaded them, so like if
No,
I do
you
so,
don't worry about this. I have access.
okay, sir. So paper title is enough.
Yes, yes.
Excuse me, sir.
Thank you.
Yes.
Sir, like for if you told us to put the paper title, no, sir. So can we put the screenshot of the title so that even the authors will be in it instead of typing it? Can we put the screenshot?
You please type it. See how many projects teams are there. Morning batch, evening batch. I'll get around 35 teams. 35 into 20. You think about it. How many papers I can go through these papers? So if you give the screenshot, I have to copy paste it and I have to search it. So what is the issue in copy pasting the title?
No, sir. I'm just asking. Can we screenshot or we'll copy paste it? Sir.
It is easy for you. Even
Yes,
copy pasting the text is easier for you, but I don't know why you want to go for a screenshot. I don't understand. I need a title of the paper so that I can easily copy paste it and somewhere. If you give me the screenshot, then I have to type it myself.
Yes, sir. Sure, sir. We'll copy paste it.
Okay.
Sir, is there any book we can refer to for the materials of the subject?
Sorry?
Sir, any book we can refer to for the subject regarding the subject? Sir?
I have uploaded, right?
Yes, sir.
Natural language processing. Yeah, then what?
Go to course page and download the syllabus.
In course page, you can find it, right?
Okay, sir.
Yes, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.